Alright, this is tutorial 6, I think so, yeah, tutorial 6, and this is where we stopped in tutorial 5, where we talked about Lagrange multipliers, and we are able to deduce 3 equations to be able to solve the 3 unknowns, the Lagrange multipliers for the vectors A, B, and D, and I expect you to solve this system of linear equation to give me the value of A, B, and D. So if you got it correctly, you have A is equal to 1, B is equal to alpha A is 1, alpha B is 1, alpha D is minus 2. So this is what you have. If you are in doubt, you can put in these values back into those equations we already have, and then you see that it makes sense. Alpha E is what? Is 0, as you know, because it doesn't have anything to do with the decision boundary. I remind you to subscribe to my channel. Click on subscribe button below this video so that you at least motivate me to do more. Alright, so at this point we have actually solved this problem. We've actually used support vector machine to classify this data set we have by finding the values of W, the value of B, and the W of alpha I for I is equal to 1 to n, where n is equal to the number of the data sets that actually lie in the gutters or actually make up the support vectors. Okay, so what next? I want to tell you congratulations. At least you now can solve support vector problems. So now note where we started. You get the equation of the line. That is the starting point. And then you start playing around with the equation of the line until you come here. So we use 3 points because we can solve for 3 points easily. But if the points are more than 3, most likely you may not have to do that manually. You need to do it using a machine learning tool or software application to do that. That we are going to talk about in a different tutorial. We also have a concept of linear separability. I'm sure you know what it means. Linear separability. Linear separability. So SVM works when data is linearly separable. So we expect that data will be linearly separable. So if you have a data set that is like this, let's just assume something like this. You have some black here. Okay, so, and then you have a different color. Let's say you have some red in here. So in this case, it's not linearly separable because you can't draw a cut line across this data. But you can also do something about it. In this case, the decision boundary is going to be something like this. Right? So how do we achieve something like this? Is by using something called Kernel. By using something called Kernel. A kernel, let me go to the next page. So that is introduction to Canal Functions. Basically, you don't need to know everything about Kernel, but I need to tell you the basics of Canal Functions. So Canal Functions are applied when data is not linearly separable, as you can see in this example right here. So if you apply Canal Function, you'll actually transform the data and then you'll be able to separate it in different dimensions. So you apply a transformation using a kernel function and replace the dot product with another function called the kernel, which transforms the space. Actually, the data is not transformed, but more like you actually transform the space. Maybe you can actually rotate the space and be able to see your data separated. So how does it work? It's of the form KUV. It acts on 2 vectors and produces an output. So here we already have class of a vector is given by the sign for positive and negative, and we know that this. So if you apply a kernel function, this is what we'll have. K xi of x, because we have, let me explain to you, maybe I'm too fast, maybe x and x. So if we apply a kernel function, we are going to apply a kernel function to these two. The reason is because this is constant, it doesn't change, this doesn't change, this doesn't change, but these will change depending on the particular data, the particular vector. So you replace this with a kernel function and you have something like this, right? Good. So this is basically what you should know about kernel function. They are applied when data is not linearly separable and actually transforms the space where the data is presented and is able to separate this data. Some common kernel functions are the linear kernel function. It applies to two vectors and produces these outputs. We have quadratic kernel function. It produces this output. Polynomial kernel function, try to read it up, and also radial basis kernel function, try to read it up. If you need me to explain it to you, if you have some interest in learning it, let me know in the comment box below. And I'd like to thank you for completing this tutorial on a support vector machine. I'm planning to prepare another tutorial where I can actually solve another support vector machine problem, maybe one that have an equation that is not very simple. The one we solved was x is equal to 1.5. Maybe we can solve something else, maybe y is equal to x, 2x plus b or something. So I'm trying to figure that out and then let you know. But for now, this is actually what you expected to know about support vector machine. Thank you for viewing. Subscribe to my channel, share around this video, share it with your friends or other students who may want to learn. All right.